using graphing. And we have a few different standards that we're meeting. The first one is 6 RP 3A. 6 RP 3B. 6 NS 8. And 6G3. Those are the standards that we'll be addressing in today's lesson. So Angela's driving to the Raccoon River. The distance traveled D miles after T hours is given by D equals 40T. Graph the relationship between D and T. Use 2 units on the horizontal axis to represent 1 hour and 2 units on the vertical axis to represent 20 miles. So here we have our table, time T hours, and our distance traveled D miles. And first we have to figure out what type of graph it is. Well, based on the equation that we're given, we will be able to say that this is a linear graph or a straight line graph because it will form a straight line for us. Excuse me. So first thing we have to do is set up our coordinate plane. And so we're told that 2 units on the horizontal axis represent 1 hour. So if we come down to our x-axis, we know that 2 units represents 1 hour. So we're going to label every other line. So there would be 1, 2, 3, 4, and 5. And we do have to label because we are going up by a different interval than 1. If we were going up, if every unit represented 1 hour, then we wouldn't have to do any labeling because that's our default setting there. Okay, so now we need to do our y-axis. And it says 2 units on the vertical axis represent 20 miles. So in other words, every unit is going to represent 10 miles. So again, we can do every other. We can go 20, 40, 60, 80, and 100. So there we've prepared our x-axis and our y-axis for our graph. And so now we look at our table and we look at our first order pair. And our first order pair is right here. And so that first order pair is 0, 0. So I'm going to plot my point at 0, 0. Then I go to my next order pair. And my next order pair is 140. So from the origin, I go to the right 1 and then up 40. And I would end up right here. And then my third order pair, because we always need to do at least 3. That way we can make sure that they are on the same line, or we're going to know that they're not on the same line, is 280. So I go to the right 2, I'd go up 80. Excuse me, and I'd plot my point. And once they're plotted, I apologize, my line's going to be a little bit squiggly here, but overall, that's not too bad. And it's going to continue off in that direction. Okay. So now I have some questions I need to answer based on the graph. So the first one is, how far did Angela drive in 3.5 hours? So there's 3 things I can do. One is I can use this equation because I know that 3.5 is the amount of time, so I can plug that into my equation and solve for the distance. Or I can use my table. I have a value for 3 hours, I have a value for 4 hours, so I could figure out the value for 3.5 hours. And finally, I have my graph. I know that 3.5 is here, and so if my graph extended farther, I could go up from 3.5 to where it hits our graph and then go across to the y-axis. So multiple ways I could get to that answer. Okay. Excuse me. Well, I'm going to use my equation. I know that distance equals 40t. So distance equals 40 times 3.5 So the distance is 140 miles. What is the speed at which Angela is driving? Well, if we go back to our table, we see that in 1 hour, she's gone 40 miles. So our speed is 40 miles per hour. Excuse me. Angela has driven for 4 hours. If she drives for another hour at this constant speed, how far will she drive in all? So again, we have two options. We can use our equation that we have here, or we can use our table and we can figure out, okay, well, this is how far we go. We know she goes 40 miles per hour. How far would she go in another hour? So there's a couple different ways, again, that we could solve this, answer this question. Well, we'll use our formula again. We know that distance equals 40 times time. She drives for another hour. Well, that would mean that she is driving for 5 hours. So distance equals 200 miles. So again, there's just multiple ways to solve that by using your graph, using your equation, or using your table to answer some of these questions. If Angela wants to drive at least 120 miles, how many hours will she need to drive? Express your answer in the form of an inequality in terms of t, where t stands for the number of hours. Okay, so we know we're going to have an inequality. So let's start with t. And let's look back at our table. Well, on our table, we do have 120 miles. And that 120 miles took us 3 hours. So, excuse me again, I apologize for that. So we want to know how much time. Well, our time is going to be compared to 3. And since it says at least 120 miles, that means we can't go exactly 120 miles. So we could drive for exactly 3 hours. So we're going to have the equal to portion to that. But when it says at least 120 miles, it means every other value we want is greater than 120, which means we'd have to drive for more than 3 hours. So t is greater than or equal to 3. And then for part F, our dependent and independent variables. Well, the independent variable is the one that we have control over. The one we have control over is the amount of time. So that is our independent variable. And our distance is dependent on the amount of time, which makes d our dependent variable. A car, excuse me again, a car uses 1 gallon of gas for every 20 miles traveled. I'm having trouble reading today. The amount of gas left in the gas tank, x gallons, after traveling y miles is given by y equals 240 minus 20x. So we want to copy and complete the table, and we're going to graph the relationship between x and y. And we're going to use 1 unit on the horizontal axis to represent 1 gallon, and 1 unit on the vertical axis to represent 20 miles. Well, first let's go ahead and fill in our table. Okay, so our amount of gas, x gallons, we go 12, we go 10, then we skip a spot, and then we go to 6. Well, between 10 and 6 would be 8, and then after 6 would be 4. And we know that because if we look at our distance traveled, we go 0, 40, 80, 120, 160. That's a constant change. So our amount of gas also has to have that constant change there as well. Okay, so it says that we use 1 unit on the horizontal axis to represent 1 gallon, which means we don't have to do anything with our x-axis because the default setting is for every unit you go up, it is 1. So when we look at our vertical axis, it says 1 unit on the vertical axis represents 20 miles. So we would have to make a change on our y-axis here. Again, we can go every other. So if 1 unit represents 20, 2 would be 40. Our next one would be 60, and then 80, then 100, then 120, 140, 160, 180, 200, 220, 200. Excuse me, I apologize for this. And mine is a 12 by 12, so that allows me to go up to 240 and not just 200. All right, so what type of graph is it? Well, it is also, once again, a linear graph because we have a linear equation. And so let's go ahead and plot the points. So the amount of gas, or my first order pair, is 12, 0. So since my first order pair is 12, 0, I'd go to the right 12 and up 0. So that's my first point right there in that lower right-hand corner. Then my next order pair is 10, 40. So I'd go to the right 10 and up 40, which would be right there. Next order pair is 8, 80. I go to the right 8 and up 80. And so I'm right there. So I have my 3 points that are needed to form the line, and I apologize for coughing once again. Hopefully this cold will go away soon. And I'm going to draw my line, and I'm going to connect. It's going to be a little bit squiggly, and I apologize for that, but this would be my line right here. And I want to try and make it as straight as I can. That's pretty long distance to go freehand without a ruler or anything, but when you do it on your own, you can use a ruler or something with a straight edge to help make that line a little bit straighter. So this would be my graph for this equation. So let's answer some remaining questions on it. Possibly if I can get to the next page. There we go. All right, so first thing we want to know is how many gallons of gas will be left in the tank after the car has traveled 60 miles. So we come back here. We know that 60, we could either put 60 in for Y, or we know that 60 falls in between those. So the answer would have to fall in between those. So here's how we can use our table. 60 is halfway between 40 and 80, which means it'd be halfway between 8 and 10. Or we could use our graph, where we know that 60 is here. So we could come across, here's where it hits, and then we can come down here. So either way we do it, we know that there would be 9 gallons. How many gallons of gas will be left in the tank after the car has traveled 100 miles? So again, we can look back and kind of that same idea here. We know that 100 would fall in between there, so it would fall between here. Or we come to our graph, and we know that 100 is here. So we come across, we would come down. Either way, we know that it would be 7 gallons. After the car has traveled 160 miles, how much farther can the car travel before it runs out of gas? Okay. Well, if we know that the car can go 240 miles in our equation, when it goes 160 miles, we know that it could only go 80 miles. Because we do a 240 minus 160. If the car travels more than 40 miles, how much gas is left in the tank? Okay, so let's take a look at our table. Okay, so we've got 40 miles here. There would be 10 gallons left at 40 miles. So we want to figure out how much gas is left in the tank. So we know that X is going to be compared to 10. Well, if we travel more than 40 miles, we're not going to be equal to that, but The more we travel, the less fuel we have. So x would actually be less than 10. And then for our independent and dependent variable, if we look at our table, another way to know you're independent and dependent, your independent is always on top, your dependent is always on bottom. So your independent is x, your dependent is y. And here's our final, excuse me, I apologize. Our final example here. Sarah plants a seed. After T weeks, the height of the plant, h centimeters, is given by h equals 2t. We're going to complete the table, graph the relationship, and move on. Okay? So if we take 0 and put it into our equation for 0, 2 times 0 is 0. If we have 4, we put 4 into our equation. 2 times 4 is 8. And if we put 5 in, we get 10. And again, we could figure that out because there is a constant change there. What type of graph is it? It is linear. What is the height of the plant after 3 weeks? Well, that would be 6 centimeters, as it tells us in the table. What is the height of the plant after 5 weeks? Well, that is 10 centimeters, as it tells us in the table. And see, we've been able to answer all these questions so far without having to look at our graph. Excuse me. What is the height of the plant if less than 4 weeks have passed? Express your answer in the form of an inequality in terms of h. So if it's less than 4 weeks, so the height of the plant would have to be less than 8 centimeters. Name the dependent and independent variables. Well, the independent variable is t. The dependent variable is h. Okay. And then finally, we will do our graph. So let's look up here. 1 unit on the horizontal axis represents 1 week, and 1 unit on the vertical axis represents 2 centimeters. So there's no change that we have to make with our x-axis. With our y, we're going up by 2s. So we would have 4, 8, 12, 16, and 20. So we come all the way back up here. Look at our first order pair is 0, 0. I apologize for going back and forth on you. Come back up here. Our next order pair is 1, 2. So we go right 1, up 2. And then our next ordered pair is 2, 4. And then connect. And that is all for today's lesson. As always, I hope this helps.